Try to solve another Leetcode problem, 1705, maximum number of eaten apples. So we are given two arrays. So the first array gonna be the apples. Yeah. So this means on the first day, and this tree have one apple, and on the second day, this tree gonna have two apples. Yeah. So for each of the tree, it will grow apples I. Yeah, but there's going to be a time. So for example, for the first day, it has one apple, but after it can only keep for 3 days. So this means the first day is okay, the second day for this apple is okay, but on the third day is okay, but on the next day or the first day, this apple gonna be rotten. Yeah. So let's just make a drawing for this problem. So for this problem, normally we're gonna eat the apples if it is close to rotten. So for example, for an apple, if the let's just have an example. So for example, I have 2 apples, so the rotten day will be 4. So the first index, this one gonna be the rotten day, it's gonna be 4. And I have another maybe another 2 apples, so the rotten day gonna be 5. Yeah. So currently I am in day 4. Yeah. So I'm in day 4, and which apple I gonna eat? This one or that one? Yeah, because if I eat this one on day 5, I finished to eat 1 apple. But I cannot finish to eat the day 4 because the next day gonna be day 5. I can only eat 1 apple. And because one day I can only eat 1 apple. So what about if I eat the day 4? I eat the first one. So on day 4 I eat the first one. So I eat 1 apple. And then on the next day it's gonna be day 5. Yeah, because this is day 5, and this one, there's still 1 apple that is rotten. That is okay, but for this one, it is day 5. I have 2 apples, so I can eat another one. So it's gonna be 1 plus 1. It's gonna be 2, and then it's gonna be day 6, and those apples gonna be rotten. Yeah. So the idea is that I always want to eat the apple which is close to rotten, which is close to the rotten day. So if this is day 4, it is day 4, and I always want to eat the apple which is close to day 4, so it's gonna be 4. Maybe I don't have this 4 and 2, maybe I have another one, maybe 6 and 1. It means on the there's 1 apple. It means on day 6 it will be after day 6 it's gonna be rotten. So first of all, I gonna eat this one. It is on day 5. Yeah. So this is the idea. So another idea is that we just record which day the apple gonna be rotten. Yeah. So maybe let me just make some points. So it means on some days the apple gonna be rotten. Maybe this is 1, 2, 3, and 4. It means on day 1 there's 1 apple rotten. On day 2 there may be 2 apples rotten. On day 3 maybe there are 2 apples rotten. On day 4 it may be 2 apples gonna be rotten. And what I gonna do is I just need to keep recording of which day it is. So currently, for example, if this is day 5, so this means all the apple before day 5 is gonna be rotten. Yeah, and all the apple it is including day 5, and after day 5, for example, this is day 6, I have 1 apple. Or day 7, I have 2 apples, and on day 5, I have 1 apple. Yeah, so this means all the apple at day 5 and after day 5 I gonna keep it, but all the apple before day 5 it's gonna be rotten. Yeah, so this means from here I can eat all those apples, but what I gonna eat is always the smallest day. It's gonna be this day 5. So according to this idea, we're gonna use a priority queue. Basically it's a min heap to solve the problem. Yeah, because inside the min heap we're gonna check the last day the apple gonna be rotten. So all those ones are gonna be pop out of the min heap, and all those ones gonna be put inside the min heap. Yeah. But while we are checking, we're gonna check the smallest day. Yeah. yeah, which gonna be this day 5 first. Yeah, so if there are 2 apples, it's gonna be reduced to 1 apple. Yeah, and then it's gonna move to the next one, and it's gonna move to the next one. Yeah, so this is the idea. So this seems we can solve it by using the greedy idea. So it's gonna be a min heap. So if all the rotten days is before my current day, so that means all those apples are gonna be pop out of the min heap. And then if all those days that are gonna be more than or equal to my current day, it will be put inside the min heap. And then I'm gonna check this min heap. So if there's apples inside, basically I'm gonna record it, and the apple gonna be reduced, and I'm gonna check one by one. Yeah. Now let's just use this idea to solve the problem. So we're gonna prepare a priority queue, and I'm gonna prepare index I. It means I'm gonna start from the ith day. Basically, it is the 0th day, and then the first day, second day, and so on and so forth. And I'm gonna have a result that's gonna be my final result. So I'm gonna be starting from 0, and the result gonna be 0. And finally, I'm gonna return the result. Now we can start the priority queue. So I'm gonna check the index I. So while I is less than the length of the apples, that means definitely there's some apple. Definitely there's some apple inside the apples array, and I would to put it inside the priority queue. Or I've already put everything inside the priority queue, or there's something inside the priority queue I can still check in. Yeah, I can still check. So this is the condition. Now I want to check the priority queue. So while pq and pq 0 0, yeah, so inside the pq actually it's gonna be a tuple. It's gonna be the rotten day. It means all which day it's gonna be rotten, and another value it's gonna be the number of the apples. Yeah, so that's gonna be the meaning of the priority queue. So the first one is gonna be the rotten day. So if this rotten day is less than and equal to current day, so this I is the current day. So for example, the first one it is 1. So 1 plus 3 is gonna be 3. So while this one goes to, this is 1, 2, 3, while it goes to here, this means the first apple gonna be rotten. So this is the idea. Yeah. So if it is rotten, definitely I don't need to code it. I just need to pop it from the priority queue. Yeah. So this is gonna be the first step we're gonna check. So next, we want to put something inside. So we need to check if I is less than the length of the apples, and if there's some apples inside the apples array. So the apples I is more than 0. So this means I can put all those apples inside the priority queue. Basically, yeah, according to the drawing. So this is my current day. It means after that, if there's an apple, I want to put it inside, basically. So the heap gonna push priority queue, and currently I'm gonna use array because later on I want to get access of the values from the array. If I use a tuple, I cannot do that because I will update the number of the apples inside this array. Yeah, so this gonna be the rotten day. So the rotten day gonna be I plus days I. So this gonna be the rotten day. It means on this day it will be rotten. So for example, the first one is gonna be I0 plus this day 3. It means yeah, on day 3 it's gonna be rotten. So the 0th day, first day, second day, and on the third day it's gonna be rotten. Yeah. Now if I put something inside, definitely I want to check this priority queue. So if there's something inside, and I want to, yeah. So if there's something inside the priority queue, basically I want to count it. So the result would plus equal to 1, and the PQ with 0, 1, because I want to update the minimum value. Yeah, so the PQ0 gonna be the minimum value, but I want to update this number. It's gonna be PQ01. It's gonna be minus equal to 1. So if PQ01 equal to 0, basically I want to pop it out. Yeah, because the number of apple equals to 0, I don't need to put it inside the priority queue. I don't want to keep it inside. I just want to pop it out. So I want to pop out the priority queue. Yeah, so this is going to be the idea of solving the problem. Now let me just run it to check. The list go out of range. Yeah, because here I just put a rotten day, but I didn't put the number of apples inside. So here basically it is the apples I. Now let me just run it. Yeah, I think I forgot to update this I, because after that, if everything's okay, I'm gonna move to the next one. I'm gonna move on to the next day and to put it inside to check. Let me just run it again. Yeah, as you can see, it works. Now let me just submit it. As you can see, it's pretty fast and it passed all testing cases, and the time complexity is n log n. So this is the n log n gonna be a small value. That is why it's so fast. I think the difficult part is how can we design this kind of a priority queue. Basically, it's gonna be a tuple of rotten day and the number of apples. So if it is less than or equal to my current day, it means all those apples are going to be rotten. So I just need to pop it out. And if it is not rotten, I'm going to choose the closest rotten day to my current day. That is why we can use a min heap. And if there's something inside it, definitely I'm going to update the final result. So if the number of days equal to 0, definitely I would to pop it out. Yeah, so this is the idea. So if I don't pop it out, let's just check what's gonna happen. Yeah, because if I were to put something inside, definitely this apple's I is more than 0. I want to put it inside. If I don't pop it out, it means there's still something inside the priority queue, and if I check it, if there's something inside the priority queue, I have to check if this number is more than 1. I'm gonna update it. So if I don't check it from here, I have to check it from here. So if PQ 0 1 more than 0, I have to update it. Yeah, but if I don't pop it out, the priority queue gonna become bigger and bigger, and this is not a good way to solve the problem. Let me just run it. It didn't work. Yeah, let me just recover it back. I think we cannot solve it like that. We have to check this the number of apples. If it is equal to 0, definitely we want to pop it out. Yeah, I think that's all for it. Thank you for watching. See you next time.